If you recall, yesterday we started talking about linear functions. We want to continue talking about linear functions today. Actually, I don't want to talk as much about linear functions, as you can see by this stack of papers that right here, that we're going to be doing stuff. But the idea with linear functions is that we start with our base constant function. Start with your constant function, which would just be like your base. And we know that this is going to look like a horizontal line. Start with your constant function. And then tilt your line in some fashion, according to some slope. So add some soap, not some soap, add some slope for some flare. So y equals 5, let's say, I don't know, minus 1/4 x. I put this too high, so I can't go up, so I'm going to go down. So I go down 1 and right. So there's your line y equals 5 minus 1/4 x. That 1/4 means something. It's the ratio of how much we go up divided by how much we go across. We can use things like rise and run because there's only 2 variables running around. As you know, today, we are going to be having 3 variables running around. So we're not going to be able to say rise and run. That's not specific enough. So this is the rise over the run, or we could think of it as how much y changes divided by how much x changes. The change in y divided by change in x. So slope is the rise over the run. Specifically, the change in y divided by the change in x. We can interpret the negative 1/4 as minus 1/4 when x increases by 1, or down 1 and right 4. Because it's just a proportion, we can split it up however we want. Questions? So start with that flat line 5, and then add some angle to it for some flare. But just one piece of flare. You don't need 37 pieces of flare, just one. Things were very simple here because we have a function of one variable. A function of one variable will be a one-dimensional curve in two-dimensional space. We have upgraded this. We're now going to look at a function of 2 variables. And yesterday we talked about what that would look like. A function of 2 variables will produce a 2-dimensional surface in 3-dimensional space. So a function of the graph of y equals f of x is a one-dimensional curve in 2-dimensional space. What we want to do today is upgrade our function of one variable to a function of 2 variables. a function of two variables will produce a two-dimensional surface in three-dimensional space. In particular, a linear function of two variables will produce a plane in R3. So a linear function of two variables plane is a specific type of surface. It's the easiest, most boring of surfaces. That's why it's our favorite. Just like a line is the easiest, most boring of curves. That's why they're our favorite. Linear functions make flat things. Thinking of linear functions of one variable, we start with our constant function, like as the base, our flat line, our horizontal line with zero slope. And then we added one angle, just added one slope for flare, right? So since we're thinking of upgrading, we specifically added one slope for some flare. We are going to do the same thing with a function of two variables. We're going to start with a plane, a horizontal plane. It's going to be a z as a function of x and y, so it'll be a plane parallel to the xy plane. And then we're going to add two slopes for some flare. A slope in the x direction, oops, I did it up this way, and a slope in the y direction. So we're going to do the same thing, and we're going to do that with this particular function. Any questions? Hopefully I don't have any typos because that throws everything off. So I got a table of values for this function, z equals f of x, y. The metadata strongly suggests that this is a linear function, but you need to figure out what is it besides that that tells you that we're dealing with a linear function. So take a moment, examine this, and then we're going to break into groups and discuss. All right, let's pause for a moment since we're pretty much out of time. So it looks like everybody has got the equation. You know what the equation should look like. For those of you wondering how we could, what I'm looking for is how you can read what's going on in the table. What's happening to z when x changes? What's happening to y when z when y changes? So everybody is on board. Everybody is on board with the equation of a plane. And a lot of you had the right idea to try to find some kind of cross product. Finding some kind of cross product is a great idea because if you find two vectors in the plane the cross product of those vectors will be perpendicular to the plane. So you could do some more work on that. One group does seem to have some secret math knowledge about how we rewrite equations and what those coefficients tell us. We will look at that in more detail tomorrow. Any questions before we adjourn? All right, things that need to happen. Make sure the pens are capped. Make sure they're back in the trays. That's 2. And number 3, please drop off your cards on the way out. That's it for today. I will see you all on tomorrow. Everybody have a good day. And thanks for playing. I don't want the paper. You can work on that still.